I knew I stopped. I knew I shouldn't be sniffing glue today. All right. So I want to go back section 1.3 for a moment on the notes, and I just want to cover it a little bit more. And the reason is I kind of goofed this a little bit. Can I dim these lights? It just seems. Is that all right? Can everyone still see your notebook? Anybody scared? I do have a night light on. Gotcha. That's coming. All right, so I want to go back and I want to talk back about this. Okay, so we have to look at this. So remember, disjoint means if it was a disjoint event, the Venn diagram looks like this. That means that if I was going to do a single situation, if I was going to do a single event, if I were to say, I would like to draw one card and it be a king or a 10. This would be disjoint because kings and 10s aren't going to happen. Right? So disjoint means that. So if it's not disjoint, that means that we're going to have an intersection of the two. So this is one event or the other is going to happen, but not both will happen at the same time. This can be, you have this event or this event, and the merge of the two could happen. Okay, so the bottom Venn diagram is you have a 40% chance of rain today, a 50% chance of rain tomorrow. What's the chance that it rains both days? That's the intersection of the two. But we got to go kind of basic on this. So there was one that was, what is the probability that you roll a die and it's a 2 or an even number? Wasn't that one of the examples in there? So this is going to be a little bit different, and I apologize. I went a little deeper than I should have, and I apologize. So I have to realize that a 2, the probability of getting the 2 is 1 out of 6 as far as that single die goes. Do you agree? As far as the even goes, the probability of even, that's going to be 3 out of 6 events taking place. But being the 2 is also an even number, so far we have here and here down here. So technically this is going to take place. Now we have to focus on the minus that. And this is going to kind of look silly for a moment because we're going to subtract the probability of A and B are going to take place. Well, the probability of A and B, there's only 1, 2 in the deck. So I'm going to subtract that 1, 2, which happens to be even out of it. So look, this is kind of funny. I have the 1 in 6 probability, but then I'm going to subtract it. So this answer is 3 over 6, or half the time this is going to take place. Now, that's a little bit different than I said yesterday because I had actually multiplied the events together with the probability of A and B, but the probability of A and B, if it's not disjoint, is going to be a little bit different on the single outcome. I'm rolling one die one time. I roll it. It's over against the wall. I want to know if the probability is even or a 2. So it's half. Okay? I didn't get to the basketball, football example below, did I? Okay, so I just had to step back a little bit for that. All right, so let's look at number 2. Example number 2. Is that okay? In example number 2, we are going to talk about, we surveyed these kids, and these kids liked football, basketball, lacrosse. Some liked all 3. Some liked 2 of them. These 2 or these 2. Some liked only the individual. So we want to create a Venn diagram. So we found out that 70%, which is 0.70, like football, right? Is it okay if I use an F for football? Because everyone will be able to catch on. Okay. 25%, which is 0.25, like lacrosse, and we'll put an L for lacrosse. Is that okay? God bless you. And then 55% chose basketball. B for basketball. Then from there, 5%, God bless you, 5% chose all three. And then from there, we had 15 were football and lacrosse. 10% chose lacrosse and basketball. And then the last one was 30% chose here and here. Now, I have kind of a really bad graphic organization of this, but we want to make a Venn diagram to take place. Was there any other choices as far as our example goes? Nope. Okay, so let's create a Venn diagram with 3 circles. So I have circle 1, I have circle 2, and I have circle 3. So I have the intersection of the green and black, black and green, or black and blue, blue and green, and then I have the intersection of all 3. So we'll call this one football, we'll call this one lacrosse, we'll call this one basketball. Okay, so let's start filling this out. So football is 70%. And of those 70%, we're going to start docking away from it. Lacrosse, we had 25% or 0.25. Basketball, we had 55%. And then the intersection of football and lacrosse, we're talking 15%. All 3 is 5%, so that's 0.05. Lacrosse and basketball is 10%. And then football and basketball is 30%. Okay? So, I want to take a look at something and make sure we get this right. We said 70% liked basketball. And of that 70%, 15% also liked lacrosse. And of that 70%, also 30% of those kids liked basketball. And of that 70%, 5% liked all 3. So I need to modify this right here to what? Yeah. 20%? How are you going to get that?
So you take your 70%,
Uh-huh.
and then you're going to subtract 15%, 5%, and then 30%.
Exactly. So technically this whole circle here is going to encompass 70% of the kids choosing football. But it's not 70% are in this region here. Of that 70%, you had these that we have to subtract away. So you said 20% because that was 0.7 minus 0.15 minus 0.05 minus 0.30, right? So 20%. So that means 20% of the students are exclusive only to football of these kids that surveyed. What about that 25% for lacrosse?
It wouldn't be right because it adds up to 30%.
So we have an incorrect portion. Let's go to the, so this is, because we have 15% like both, 5% here, 10% here, that adds up to 30%. So we have a negative 5% up here. Oh my gosh. What about basketball? So this is actually going to give us a wrong answer because we're going to get a negative 5% of the kids are exclusive to lacrosse only. And then the basketball. 40. How much should your basketball be? 10%? Let's see. 40, 45. Yeah, 10%. Good. So this is 0.1 actually. Okay. So I apologize that the lacrosse is wrong, but I think we can answer these questions even though the lacrosse is wrong. Technically, that's how we would draw our Venn diagram. What percent of the boys would pick football or basketball? So football or basketball. Did I write something wrong? Yeah.
I'm confused. Why does the 15 in green, the 10 in green, the 5, and the 30 to the left in green not add up to 100? Shouldn't they? Yeah. Up in the upper graph.
This one?
No, in the chart.
Oh. It was because I gave you 3 choices, and I'll say pick 1 to 3 of these choices.
So they just pick more than one. Mm-hmm.
So 70% of the class had said football, but that football might have been they wanted basketball and lacrosse as well. So like, and then of that, 20 only be that 0.2, the 20%. That would have been of my surveys. Only 20% would have come back having football exclusively. Okay. So what percent didn't pick any sport? None of them. What did I do?
Well, I was so for
B.
the percent of boys who pick football or basketball, it would be 60% because you include the people who pick both, the people who only pick basketball, and the people who only pick football. Because it's either or, not just both.
What percent of boys pick football or basketball? So that's probability of A plus probability of D minus probability of A and B. That make sense? So, football and basketball, right? They chose football or basketball. Okay? So, football is, we could look at it a couple of different ways. We could say, this was exclusive for football. This was exclusive for basketball. So, who picked football or basketball? 30%. Is that what you said? No.
Well, but I included the people who picked both, so.
Oh, I see what you're doing. And I agree with what you're saying.
But would I not because it's an or not?
So as far as the or goes, this region right here is the 20%. And then this region right here is the 0.1% or the 10%, or 0.1 or the 10%. And so I think we could say 30%, as God bless you, would choose to do that, because then we're eliminating the ands and the alls. What percent? I'm going to skip C just because our lacrosse data is wrong.
Wait, so for B, just 30%?
Just 30%. So the football, people who just chose football alone was 20%. People who choose basketball alone was 10%. So
But
20.
then why wouldn't you? But then you're like subtract. Why?
Oh, okay. So if I were to do it that way, I'd go the probability of this is 70.
Oh.
But I already did that work.
Okay, that makes sense.
Does that make sense?
Yeah.
I'm not going to do the lacrosse and basketball just because our things are goofy. So let's move on. Let's talk about dependent events. And this is going to start a little bit goofy. So let's talk about a deck of cards. So you're going to draw 2 cards, and let's say that the 2 cards, I want them to be both aces. Okay? But this is how I'm going to play this game. I'm going to do this. I'm going to draw two cards. I'm going to lay them both flat. Still with me? So I lay them both flat. And I'm going to pick up the first card. If it happens to be an ace, then I will look at the second card. Does that make sense? If it's not an ace, I'm just going to not worry about it. So this is taken into account. So we have the probability of A and B is equal to the probability of A times the probability of B such that A. That means that A and B are dependent. So the first event has to happen for the second event to take place. Okay? This is a lot of times how a lottery ticket will go. Sometimes those scratch tickets that you can buy, and I know none of you will buy them because you've all learned that gambling is not good. Sometimes you can scratch one, and if you happen to have a prize there, you can scratch a second to try and improve that prize. But if you don't have a prize on the first window, then there's no reason to scratch the second one because you can't win regardless. Now, most people are going to scratch it all off anyhow just to see what all the pictures were underneath. But let's say, you guys ever watch The Price is Right? You know the board that they have up, and there's 9 different 2-digit numbers up there, and you find the front and the back of the car, you win the car. But you get like 4 guesses, and then if you guess all wrong and you don't get the front and back, then they sum up the numbers, and you get, oh look, you get $216, good for you. So that's kind of this game. If we weren't going to pick multiple times, we're going to try to get the front and the back of the car. If we pick the front of the car, what's the probability we get the back of the car such that the front of the car had already been selected is what we're going with on this picture. Okay, so P parentheses A, so if I have it like this, this means the probability that B will happen given A has already taken place. B will happen given A already took place. So let's talk about the ace and the ace. Okay, I want to know what the probability of me drawing an ace and an ace. But I don't want to choose again. I want to put 2 cards down. I'm going to pick up the first card. If it's an ace, I'm then going to flip the next card to see if it's an ace. Okay? So probability of an ace and an ace. So you're talking about 52 cards. There's 4 aces. Next event, 51. Multiply those together. You're going to get your probability. This would be the same thing if it was a queen and an ace or a king and an ace. Okay? One event has to take place for the other to take it on. All right, I'm going to example 4 real quick. So you have 15 boys, 12 girls. So you're talking about 27 people. What's the probability that all 3 are boys? Okay, so you have 15 out of 27 times 14 out of 26 times 13 out of 25. Whatever that comes out to would be your answer. What would the probability of all girls be? So this is for the boys. This is for all girls. You're going to go 12 out of 27 times 11 out of 26 times 10 out of 25. You multiply that all together. That's the probability it all happens. What about if there is at least one girl? So I'm going to take whatever this answer was, this answer here, for all boys, and then I'm going to say 1 minus the all boys answer. So I'm taking the complement of it, and that's going to tell me we have at least one girl. Okay? So take the complement of all boys, and that'll tell you you have at least one girl. And then the probability of boy, girl, boy. So boy, 15 out of 27 times girl, 12 out of 26 times boy, 14 out of 25. And if you multiply that all together, you'll get boy, Girl, boy, girl. 1.3 is your homework. We will have a quiz on 1.1 to 1.3 on Monday. Have a great day, everybody.